Assalamualaikum warahmatullahi wabarakatuh. My name is Afisena Sudostan Harudin, and now I will present to you guys about power. This is my chapter test 2, tugas. So let's go. What is power? First thing first, power is a rate change of work due each time. Or you can say that how many joule over time per second often says as what. So when you got a joule and how to calculate the energy, you can just divide it by the time and you get the watt or joule per second. Okay, because yeah, I will explain detail up. So what what the fundamental things you have to know about power. First things is the equations. Power equals to work over time or energy over time, because work work is often is a energy. Okay, work is energy. Is all the same. Okay, so the power equations labeled P, and the energy is E, and the work is W. Okay, power doesn't have any direction because it is scalar. So if the question asks you the direction of the power, you can say plus and negative and positive, or you can say it has no direction because it's a scalar quantity. Okay, I just done the question, so we can rewrite this. So deriving the power equations, because this is the second fundamental things you have to know in power. Power equals to work over time. Okay, so additional information, how do I get the watt and the joule per second is from this. So what work over time equals to power, whereas work equals to force times by distance. So power equals to force times by distance over time, or force times by distance over time. You guys must be you guys often hearing this, didn't you? Distance over time is equals to the speed or velocity. Okay, let me no, you guys know, right? I mean like distance over time equals to velocity. Velocity equals to distance over time. Speed equals to distance over time. Yeah. And then we get this. So force times by velocity, or force times by speed. And then we get the two equations here. The first one is Fv, the second one is work over time. So on this thing, a tow car, okay, let's move to the example questions. A tow car pulling a car for 5 kilometers long, and weight of a car is 9,000 Newton. The tow car moves 20 seconds. Calculate how many power that the tow car have. We have to convert this 5 kilometers to meters, because distance unit is meter. Okay. Okay, so 5 kilometers equals to 5,000 meter. Okay, so we add the equation, force equals to distance. Oh no, I mean force equals to work over time, or force times by distance over time. So we get this 9,000 Newton times by the distance over 20. we calculate and we got 2,250,000 joule per second, or 2.25 times by 10 to the power of 6 watt. Okay, so now we move to the past paper. Okay, a motor is used to lift a load vertically upwards at a constant speed. Okay, so A, divine power. Power is a rate change in work over time second. So the motor lifts a load of mass 120 vertically through a height of 8 meters in 20 seconds at a constant speed. Okay, we highlight in this. Okay, at the constant speed. So you guys may actually think that this is only F times by D over T. No, because it's a vertical, which means there is gravity acting on the mass. Okay, so we use as the work equals to GPE, I mean energy, okay, gravitational potential energy. So the equation of the GPE will equals to mass gravity height. So 120 times by 9.81 times by height 8 equals to 9.417.6. I mean not 9.9417.6. Okay, this is Newton. No, I mean, yep, this is Newton. Calculate the output power of the motor. 2 marks. Okay, so P equals to W over T. So now the work is 9417.6 divided by 20 will be equals to 4. Okay, we'll input to the calculators. 9417.6 divided by 20 equals to 47.88. So this is joule per second. Okay, joule per second. So number C, the motor has an efficiency of 75%. Calculate the input power to the motor. Input is out over in times by 100 equals to 75 point over 100. So for 70.88, we just do the algebra things, you know what I'm saying, times by 100 to the power of 2 and divided by 75, when we will get 470.88 times by 100 squared divided by 75, 62.78, no, I mean not point, 62,784 Newton. No, joule per second. Okay, state and explain 2 forms of energy loss in a motor that cause the efficiency to be less than 100%. Energy loss, okay. Friction. Always remember friction. Friction on the vehicle. Okay, friction on the vehicle. And then sounds of the moving object. Sounds on a moving object, or Doppler-Geiger effect, if I'm not mistaken. The motor is now used to lift the same load in half. Calculate the new output power. So the first time is 20. We just divide it by 2, we'll get 10 seconds. Okay, so use the equation power equals to work over time, where the power is 9147.6 divided by 10, and we'll get 914.76, or 9 I mean 9149 1 oh wait, I forget, I really forget. Okay, terbalik. Okay guys, terbalik ya. What do you see? 941. Okay, 941. See, this is 941. 941 7.6 divided by 10 will be equals to 941.76, or 942 joule. And the end of the question 1. Okay, the last. Explain why the efficiency of the motor may change when the load is lifted in a shorter time. The most logically answer is, this is my logical things, okay, not from the Marxian. Why the efficiency of the motor? Okay, because the time needed is less. And then, okay, number 2, it cost more energy. Okay, this is the answer. Because why it costs more energy? So if we see the equation, when the divider is lower, so the weight is higher. No, not just like that. So if the divider is lower than the upper divider, this, you know what I'm saying, this, and then this, it's different. Yep, I can conclude that it costs more energy because the time is lower. So that's all for me, guys. Thank you for watching my chapter test 2, okay, video about presentation of work. Assalamualaikum warahmatullahi wabarakatuh.